And Bismillahirrahmanirrahim. So today, boleh tengok kan? Boleh nampak kan slide saya kan? Kau saya belum share lagi. Boleh nampak tak slide?
Belum.
Belum.
Saya belum share lagi.
Saya belum share. Okay, alright. Aduh, you can share pula. Sekejap saya terpaksa left kejap untuk restart sekejap. Okay, welcome back. Sorry ya. Saya lupa shutdown saya punya Mac semalam ni. So dia tak boleh nak share. Saya pun tak tahu siapa. Alright, boleh nampak kan slide saya kan?
Boleh nanti.
Okay, right. So, sekejap one topic then set. After this, so kita start dengan UPS. Okay, right. So, now we are going to start topic for today, which is UPS. Last week, I already introduced the topic kan. So today we try to complete topic, and this topic very simple and very short kan. So mungkin habis awal lah our class ni. Alright, the UPS, if you can see from the picture kan, this is sample of the UPS lah. Maybe you all tak pernah tengok, you never seen this UPS, and very hard to find pun. Kalau UPS biasa-biasa you tak boleh jumpa lah the UPS ni. So maybe you have found a small of UPS. Later I will show the sample of a small UPS. But what we are dealing now with the topic is we are dealing with the high spec of the UPS which is we try to talk on the how to cover of the power supply during the interaction. Let's say there are no supply from TMB, so how the other source, how the backup system can be installed to cater the supply for our electrical system. So this is sample that I have found lah in Google, which is easy. At least you got some idea. Oh, this is the UPS, kan? So tak nak you masih fikir UPS yang kecil-kecil kan. Macam maybe you have bought for your laptop you all kan. That one UPS juga, but that one is for small UPS. The concept is same, but for this design we must put it in a separate room, satu bilik, which is khas specific for the UPS. So let's say you got some project after this during your working, so you need to design or the owner request you to add up the UPS for their backup system. So you must prepare at least you got some idea, oh UPS aku kena ada satu bilik khas, so which is dalam bilik tu dia kena ada, you must have a separate room for battery kan. So at least you got some ideas, little bit ideas lah. Kalau tak, maybe you don't know anything related to the UPS. So the function is electrical apparatus that provide emergency power to alert when the input power source typically the ultimate fail. Itu yang function dia, itu backup kan, nama pun backup kan. So the best part of the UPS is it was very fast. Very fast. Let's say within a second let's say the TME trip, and automatically UPS will cover the supply. So that the best of the UPS lah. Sometimes dia do not know, oh ada tripping kan, tak tahu pun. So, macam hospital, normally hospital we are very caring on the power supply, especially building macam hospital lah, okay. And Unimap, we just care on the server ICT unit ICT. So the project UPS for ICT Unimap costing more than 2 million tau. 2 juta UPS saja. So whoever want to join the business or company UPS, I think should be good lah, good business, because right now in this era we are what we call it, aggressively on the IR 4.0 kan, which is 4.0 must be we are focusing on the internet lah. So when we dealing the internet kan, macam mana world without internet today's kan. So nak cakap the internet very important right now. So how to backup the internet tu, so we must care on the ICT part lah. So that's why the business of UPS, what I can say that very rapidly increasing time to time. So your senior also have 2-3 orang lah that has been called me that they are working on the UPS factory and company or supplier that dealing with UPS also. So I'm glad to that. Okay. So this is the sample. Yang ni small UPS ni. Maybe this is a small UPS that I believe that some of you already use macam ni, you just plug in socket. Let's say your laptop ke, your PC ke, so do like this kan. And then the high capacity, this the normal that we are dealing on this topic. Project mana-mana yang you nak backup supply, so normally we install UPS dulu like that lah. They have a right of the power supply. Okay, and then when we're dealing with very high UPS, we will use the flywheel on this concept, and that normally it will install on the factory lah. So saya pun tak expert on this part. So we need to discuss little bit on that part lah, and next time lah. But we are focusing on this part, high capacity. Okay. So as I mentioned earlier, okay, so the function we want to provide near instantaneous. Dia punya wording dia, near instantaneous. So protection from input power interruption by supply energy stored in battery, super capacitor or flywheel. So dia ada 3 benda tu lah. Which one lah? Okay, either battery, super capacitor or flywheel. So it depends on your type UPS that you are using. So normally we are dealing with batteries lah, senang nak maintain and so on. So right now they are design of a new UPS yang mahal, expensive UPS, they are using the super capacitor. So maybe lah, next time the super capacitor will be more will be used because saya tengok market semakin banyak to change to super capacitor. Okay. So this is the sample of the connection of the UPS lah. Okay, let's say this is the TNB or main supply lah. Okay, and then we have the transformer, and then this is your MSB lah. Let's say this is your MSB. Okay, and then how to connect the UPS? The UPS is connected at the load now, di sebelah load ni. The outside ni macam let's say you connect this one to DB and so on kan. As you draw dalam you punya schematic tu. So your project kan, so it should be same, and then one leg is connected directly to the UPS, and the UPS itself will be connected to this specific load that you are selected to backup during the interruption supply from the TMB. Okay, so it is different with the genset connection. So genset must be connected before the outgoing, kan? The outgoing, so which is we have supply, another supply here. So it is parallel with the transformer, kan? Macam transformer is from grid or from TNB, and this one is from the genset, kan? So all of this go to the load, but UPS is different. Please remember on that lah, because normally all engineers they are thinking that UPS connection is same with the genset. So that's wrong lah. It should be the connection of the UPS must be after load. Okay, parallel with load, macam tu connection dia, simple saja. So dia tak perlulah a lot of configuration and installation of apa macam sistem genset kan. Genset we need to have a very specific installation kan, room and the connection so on, but the UPS should be easier compared to the genset, but it still have a connection and so on lah. Okay, so dealing with UPS, we also must follow some standard lah, okay, in worldwide. Okay, the number one, we must refer to the IEE, which is under American National Standard Institute ataupun Institute Electrical and Electronic Engineers, IEE. So under topic practice for application and testing of UPS. So that katakan let's say you want to design the UPS but you don't know how the spec, so you just Google the standard, so you just refer what does UPS requirement, so you just follow. So let's say because maybe you want to design and then or you want to buy the UPS to install on your site, but you must make sure that the UPS that you want to install on your site must be comply with the standard. Ada tiga ni je. So number two is NEMA. NEMA standard worldwide lah. Mana-mana negara pun you pergi, katakan you dapat kerja offshore ke mana-mana negara kan, Jerman ke mana, you just follow the standard under National Electrical Manufacturer Association NEMA, kita sebut NEMA lah senang. So you cari under UPS, so you just follow that standard. And then the rest NEMA juga standard PE5, Constant Potential Electrical Utility Battery Charger. That one is specific for battery charger. Okay. So normally we referring to the number 2 ni. Saya pun refer yang ni je, senang. Okay. So and the best part under sizing lah for UPS. Last topic kot saya ingat ni under UPS. After this I will continue the another slide from Mr. Hatinzam. So let's say how you are going to sizing the UPS. So that's the topic. Let's say for this topic you just need to know the what we call it the function of UPS, type of a UPS, then 3. After this we go into the UPS type and then the sizing. So how you are going to sizing your UPS. Okay, this is the sample of the step lah on sizing the UPS kan. So sizing UPS dia tak sama macam you calculate your your MSB kan. But it very simple. very simple. So let's say we have this load. Contoh macam ni. So we have fire pump, escalator, lift, lighting, normal, offload kan. And then aircon and so on. And this is CR, diversity factor, maximum demand. So sama tak macam you all buat. And this table is coming from apa company tu buat? Lupa lah. Sama. I just want to highlight that whatever they are doing, so we are dealing the same with them lah kan. So kita ada connected load, diversity factor and maximum demand. So nampak lebih kurang macam kamu buat kan. So at least you appreciate lah what you have done kan. So this is coming just copy from which company tau. Saya tak ingat company apa. So but related to the electrical installation lah. So let's say okay, for the UPS they decide to connect to the essential load lah. Essential load ni benda yang penting lah. So normally the owner of the building will decide apa benda, which load that are essential to be what we call it power up without interruption. Itu kena tahu. Kan, let's say you got project apa bangunan Unimap kan. Because most of you got project Unimap. So from your project, is it have a special load that must be backup by the UPS? Ada, siapa tahu? Projek mana yang ada? Siapa? Group mana yang ada projek UPS? Tak tahu kan? Because we don't make a meeting with the owner of the building, so kita tak tahu lah. Kecuali dia mention dalam drawing tu kan. But normally we need to ask the owner lah. So real project macam tu. Because saya dah melalui proses yang banyak kali dealing with the design ni during the JKR and consultant. So normally we will have several numbers of meeting lah, and then we have a coordination meeting. So we need to know everything from the owner of the building. So during the design, so we must have the input like this kan. Overall the designer dia akan design whatever that you have done right now. Additionally we need to present, so that's why lah saya minta kamu present benda yang sama je, nanti real life you akan present macam tu lah. Tapi taklah bentuk macam you present seorang-seorang satu part, tapi nanti real life nanti only one person lah akan present the whole project tu. Takkanlah nak kena pasing-pasing separuh present tu, taklah. Okay, yang ni sebab saya nak bagi markah saja by person kan. Sebab tu kena present, you need to present only short part by part. Normally real life you need to present by your own lah, cover mechanical and electrical. You kena present seorang, you must defend. Defend tu nanti the owner, the authority, majlis bandaran, bomba, all this thing confirm nak akan tanya based on your design. Bukan saya saja saya nak test all of you to present, but we try to educate all of you, try to defend after this. Let's say benda simple je dia orang tanya, bukannya nak tanya, bukan nak menjatuhkan, nak condemn you all kan. Tanya, we want to know. Let's say why you choose that lighting. Confirm you have.
I'm here.
Confirm you must have your own answer kan. And then how does the distribution system kan. Kita tanya bukan nak condemn you all. Kita just normally the owner want to know because the idea of your project kan. You kena jawab lah, itu je. Tapi you kena prepare, kalau you takut dia akan jadi benda lain nanti. So okay, back to our business. Okay, this is UPS. Let's say lah we decide that to cater essential load, kita total up lah ada, let's say after we total up the essential load, sorry
I didn't get that.
kacau Siri pun, 76 kilowatt that we need to backup from the UPS. So to calculate the size, suitable size for UPS, so we use the formula KVA lah, because kan UPS sama macam genset, sama juga macam transformer, kan. We decide the size based on the KVA value, because kalau you refer data sheet, katanya you nak beli transformer kan, ataupun you nak beli UPS, so all of the value is measured under KVA. So kalau kita mencari nilai kilowatt, tak jumpa, confirm tak jumpa under kilowatt. So we must convert it into KVA. So kalau kita nak dapat, let's say we have kilowatt kan, katakan kamu ada 76 kilowatt, so berapa KVA? Macam mana nak dapat? Formula dah bagi ni, ada kan? So kena tahulah. So very simple. So you just use a power factor value lah. So this what we call it, this power factor is standard 0.8. This is international lah. International use 0.8, worldwide use. So in Malaysia, if you want to use 0.85 also can, pun boleh. Lagi bagus lah, maksudnya lagi bagus. That's better design lah. The standard 0.8 is enough actually. And then you have 76 ni lah, 76 ni, 76 kilowatt load. You just divide by power factor, so you akan dapat lah. The value is berapa? Dapat berapa? 76. That one, and then kita try calculate dapat. And then we add up saja 20% and 20 up to 30%. For this one, they tambah 30% lah. And so that very simple, kan? So and then let's say you based on your KVA, you all dapat 98 KVA kan, 98. So and then you refer to the data sheet that available at market. So 98 confirm lah, yang dekat is 100 KVA. So 100 KVA lah that your size of the UPS that you can choose for your project. Sama kan? Macam you select breaker bawah semua sama je, tak susah pun. So that's the how to sizing the UPS, very simple. So the only part that you must consider is essential load lah, so you need to know. So sekejap, and then this is the equipment and installation lah, contoh. So first during the installation of the UPS, first you must have the specific room for UPS, okay, which is that room must be ventilation system 24 hours lah, where contoh normally we have two aircon lah, two aircon split hour. Contoh yang aircon ni 12 hour and the another one is 12 hour. So 12 hour this aircon will on and then off, and then after that continue with this another aircon. So that room must be 24 hour air conditioning ya. So that's why lah kalau audit normally saya akan pergi check dulu server room. Saya akan check benda ni ya, server room, and then I will find the UPS, because normally audit ni dia nak cari elektrik yang banyak coming datang daripada mana kan. So kita cari benda yang 24 jam. And then we have battery cabinet. Battery cabinet kalau you tengok kat belakang ni kan, dia ada battery cabinet lah. So di another room. separate room with the UPS. Okay, sebab when we dealing with UPS, we will have a lot of number of battery. Dia not enough with one or two. It must have a parallel or series of number of battery. Okay, and then the room must be dust free, clean and low humidity. Okay, what's that? Okay, so that one I will cover next week for the genset. Now I just want to show the design from Mr. Nizam. I try open. And lambat sikit. Okay, so this is the drawing, real drawing project. Saya tak ingat kat mana ni. Which project? Okay, Pekeso. So Kedah. So dia install UPS to backup dia server room lah. Okay, this is the sample schematic that for their project lah, schematic. Same with your project kan, sama kan. Kalau yang ni dia 3 phase tapi dia buat macam ni, dia tap one by one je tu pun boleh. Macam you buat, you separate 3 terus kan, pun boleh, tak ada masalah. It depend. So bukan ini yang saya nak tunjuk. Saya nak tunjuk this UPS connection. So di UPS, mana UPS? This is the UPS. Okay, boleh nampak kan? UPS simbol dia senang. You just draw a box and you put word UPS. So that settle lah your UPS drawing. Very simple. So under UPS, firstly we must know which the essential load that must be power up lah using UPS. So let's say for this project, this only socket. Socket ni saja yang dia orang nak powered by the UPS. Tak boleh lah you bagi UPS besar-besar load. Boleh nak buat tapi sangat besar. Too big UPS confirm big price kan. Normally we cover UPS with not too much number of load lah. Okay. And then we must have the changeover, which is switching lah. Switching dia. Okay. Switching from the TMB and from the UPS. This is sample of the connection or schematic diagram. And then if you can see, this is from the main supply. Okay, and if you can see one line, okay, one line, let's say here is connected directly to the changeover and then connect to the load. Okay, meaning that this is the normal load condition. Kalau tak ada apa-apa, so if there any no problem with TMB, so this load will be powered up by the TMB lah. So with this line, no problem. Let's say when there are interruption from the TMB, so the supply, there are no supply from here kan, so tak ada supply. So the switch changeover will be placing to here lah, automatically bukan not manually. So this changeover will be automatically. Automatic, it will directly transfer to here and then breaker and then connected to this UPS. Okay, so the supply will be powered up by this UPS to the load. Simple je. And then during the normal load actually kan, actually dia supply ni akan masuk juga ke UPS, which is the UPS will charge the battery. Macam tu. Cuma the load from the UPS is not directly to here lah. Tak masuk kan, sebab switch is, the changeover is connected to the grid kan. So this switch the main lah. Kalau you design UPS without changeover, so nanti bila you on supply, meletup sini. Because you have two supply at the same time Kan UPS and grid dia dapat mana tu? Kan bahaya. So please make sure Okay, settle. Mana dia? Okay. And this is slide from Mr. Hasnizam. And he asked to share lah. Okay. So kita masuk sekejap je lagi. Saya try to cover a little bit on this topic because class which Mr. Nizam dia using this slide. Okay, I try to standardize lah, samakan lah with the class. Okay. So the UPS solution should be same lah whatever I already explained, but I try to cover. The solution for sensitive application, word sensitive application lah, kan senang sebab normally UPS ni memang we are dealing with very rare application lah. To provide a power interface between the utility and the sensitive load, providing voltage that is free of all disturbance present in utility power and in compliance with the strict tolerance required by the load. So kita apply UPS because we want to get all of this part lah, kan, free of this disturbance, power quality lah normally kan. And then available in the event of utility outage, bila trip within specific tolerance UPS satisfy this requirement in term power availability and quality, kan. So supplying load with voltage comply with the strict tolerance through use of an inverter. So all of the UPS is built up with the inverter, kan. So providing an autonomous alternate source through use of a battery. So all of the UPS is the main component is battery lah. So autonomous meaning that when we have outage, so it will automatically switching to the UPS to backup the load. So okay, and then UPS system stepping in, dia masuk to replace utility with no transfer time. No transfer time ayat tu. Okay, and then without any interruption in supply of power to the load through use of static switch. So the name built-in. Okay, switch that built-in the UPS adalah we call it by static switch. So that static switch is electronically electronic punya switching. So that's why it was very fast compared to our breaker and manually system kan. Macam genset, we have ATF, automatic transfer switch. So the automatic transfer switch normally it will take some second lah kan, below than 5 second, below than 10 second genset. But for UPS, we use a static switch. So it's around millisecond saja. Within millisecond, dia dah dapat new supply from UPS. So our sinusoidal wave supply kan, 240 volt tu. So katakan we have interruption, belum sampai dia supply kosong, terus dapat yang baru. So dia punya sinusoidal tu maintain lah. That's good. We are using the UPS. And this is the diagram of our connection of the backup system lah. So normally we have what we call it supply from TMB. Okay. So we just go to the UPS. So ini UPS lah. Kan. And then in UPS we have inverter or charger built up in UPS. And then from UPS is connected to the load lah, our normal load kan, normally. Okay. And then at the same time during the charger, the UPS is connected to the battery. And then the battery during the normal condition, the battery is charged lah. The charge with no, and then let's say once the AC is interrupt, no supply from the TMB, so the power from battery is storage from the battery will be connected to the UPS, and then from the UPS will transfer to the AC load. Senang je. And then this is the another concept of our connection, which is we have a supply TMB directly connect to the battery charger, and then from battery charger is charge the battery lah. And then at the same time we have a UPS here. We have separate time lah, separate thing. Then AC source, transfer switch, and then connected to the AC load. Okay. Okay, item main component lah. Main component under UPS we have charger ataupun rectifier, which is produce the DC power to charge battery and supply inverter. And then number 2 we have inverter, which is produce quality electrical power kan. So and then because UPS in DC, because when we dealing with a battery is in DC. So that's why we need to have the inverter. So inverter want to convert from DC to AC. That's the function, basic function of the inverter lah. Okay, so under inverter we have free of utility disturbance, notability micro outage, and then within tolerant compatible kan. So tengok ni dia punya tolerant only 0.5% plus minus lah, plus minus. Kalau macam normal supply kan, kita ada plus 10 minus 6 kan dalam standard ST Malaysia supply kan, 230 dan 230 ataupun 400 volt plus 10% minus 5% minus 6% kan kat Malaysia. But the best of using the UPS, the output from the UPS, tengok tu dia punya standard tu very good. And then the frequency is same lah, plus minus 1%. Okay. And then number 3 we have a battery which is provide sufficient backup lah. 8 minit to 1 hour sahaja normally, yang basic lah. Kalau you all nak long time backup from the UPS, so you need to have several number of battery. And then number 4 we have static switch. So static switch is a main component juga lah dalam UPS, which is function to switch from the normal load to the UPS. And the static switch is a semiconductor based device macam as I mentioned earlier kan. So this is semicon switch which transfer the load from the inverter to the utility and back, transfer patah balik kan. And back ni when interruption dah okay lah. Katakan tadi dia no supply, so it will on. Let's say the TMB is coming back, so it will automatically switch off. So that the function of static switch. Okay. So under UPS we have 3 type. Okay, which is under standard IEC 62040. We have 3 type lah. Number 1 is offline system. Number 2 is interactive, and number 3 we call it online lah, ataupun bahasa technical we call it double conversion. But kalau you are dealing with contractor, consultant, so they just speak on this word lah, offline, online ataupun interactive. 3 tu aja. Nanti you masuk site you tak tahu pula kan. You duk kata apa? You study ada passive dengan double conversion, tapi saya geng-geng ni cakap online, offline lah. So that's why Mr. Nizam buat siap-siap dah. Bagus, siap. So normally equipped with 2 AC input, which is number 1 is normal and another one is bypass. Okay, normal AC input is TMB punya lah, utility lah. And number 2 bypass ni is from genset, standby power kan. Okay, so this is the connection, sample of connection. So this is the normal supply masuk, and this is our load lah, our load. This is for offline, offline. Okay, the inverter is connected parallel with the AC input in the standby. Okay, kalau offline macam ni, dia parallel saja. Okay, so this is our UPS. We just connect to the input kan. Same. Okay, load kita parallelkan saja our UPS, which is this UPS complete set of UPS. We have charger and inverter and battery. So during the normal mode, the load is supplied by utility power. Okay, normal. So load supplied by ni lah. And then provide some degree regulation ni macam biasa. No. Okay. And then the inverter operate in passive standby mode. So supply still coming into the UPS, and during that time battery is charged, charger charge the battery, and the inverter is work, but it on the what we call it standby mode. Dia ready dalam keadaan ready standby. So when there are no supply from TMB, it will change to the battery backup mode. So outside specific tolerance ni no supply now. Okay, the inverter and the battery step in to ensure continuous supply of power to the load following a very short below than 10 millisecond. Tambah cepatnya transfer time, so below than 10 millisecond it will have backup system. Yeah. Okay, and then from the inverter, it will send to the load. So within 10 milliseconds, so our load will get the supply. Okay, number 2 is a line interactive mode. Kan? Number 2. So the inverter is connected parallel juga, sama juga macam ni. And this is the what we call it normal load kan, macam ni load. So our connection is parallel, sama juga, tapi parallel load. Okay. Okay, but dia kata but charge the battery dalam line direct terus lah kan. Reversible operation with AC input. Okay, reversible charging dia. Okay, reversible. Okay, dalam mode dia ada 3 mode lah. Okay, 3 mode. For first mode, normal mode, the load is supplied with condition power via sama condition, tak ada masalah. Directly supply, the load is supplied with condition power via parallel connection of AC and the input and the inverter. So the inverter operate to provide, so kalau kita tengok ni during normal, walaupun normal, still got supply from the inverter was morning switching kan, lalu kan normal mode. Okay, dia static switch still work and open switch directly from normal input to the load. So when there are interruption, okay, the inverter and the battery step in to ensure continuous, sama macam tadi lah. So bila interruption, so inverter and battery ni dia akan take over supply. So sini tak ada kan, static switch control je. Okay. using static switch. So static switch will control kan. So when we deal with this one, sorry. So this system will be faster, more faster compared to the offline lah, sebab the static switch is connected seriously indirectly dalam in AC input. Okay, and then UPS continue to operate on battery until the end of battery backup time lah. So katakan sejam, so we will backup until 1 hour only. After that habis lah. And then kalau return to normal, so it will transfer back to load lah macam biasa. And then we have also the another one mode, which is we call it by bypass mode. So this type of UPS may be equipped bypass. Bypass lah, sebab model ni kelebihan dia interaktif ni dia ada bypass. And for information, make sure if you want to design a UPS, make sure minimum concept atau minimum type UPS that you want to install at least interaktif or online. Itu je. Offline ni jarang lah. Offline ni kita pakai sendiri boleh. And if one of the UPS function fail, nampak tu. Katakanlah UPS pula function fail. So the load can be transferred to the bypass AC switch. Kan? Macam mana tu? Katakanlah sebab because it said that dia selari parallel inverter, and then the static switch is connected directly dalam one way from the normal load. So katakan let's say this UPS is broke, so macam mana nanti normal supply pun tak boleh sampai kan, sebab we connected directly. So that's why let's say we want to remove this inverter for maintenance and so on. So that's why this mode we have bypass system. So this is all out in one box tau. So condition ni. So kita just we have this one is by normal manually bypass ni. We have separate switch to bypass. So in that we have input sama kita tutup sini lah. So input kita bypass, so our load still can working, and then we can make maintenance or repairing and this inverter or UPS lah. So that's good. We are using the line interactive tu. Okay, tapi jarang-jarang lah kita nak want to use this bypass, but still we have, because we have this condition previously in some project. Kita ada project sebelum ni. We install the UPS, and then ada satu masa tu UPS tu terbakar tau. Kalau pasal di Unimed Kubang Gajah, that case have been, saya ingat 2000 berapa macam tu, 2018 macam tu. Our Unimed server UPS is fired, bilik tu terbakar, bilik UPS. So the case is from hujan lah, hujan. Bumbung bocor, hujan, and then that room luckily directly to UPS room. So UPS yang rosak lah. Kan, so bila UPS rosak, that time they cannot open the UPS because the UPS is directly connected and there are no bypass. So problem lah time tu. So macam mana nak buka repair kan, padahal TMB supply is still there, and but they want to remove the what we call it, the UPS, cannot. So because the system is without bypass. So that time I think around 2 weeks juga ikut kita punya server Unimed time tu nak up balik. So that's why latest Unimed use double conversion or online, and we are installed on the ICT at Pauh lah. We are not dealing with server at Kubang Gajah at all. So semua server Unimed sekarang ni dah ada di Pauh dah. Before this, the Unimed server is at Kubang Gajah. So due to that issue, so Unimed buy a new UPS and server. So they allocate that at new building jugalah at the Pauh. Okay, the concept sama juga. It have a 3 mode, which is normal mode, battery backup, and bypass mode. So that's the double conversion. So the best UPS is you buy the online mode, online type of the what we call it, online UPS. So during normal sama lah, kan? During normal same. And if you can see, okay, this is the concept normal. The connection nampak kan, this is all of this the UPS kan. Okay, charger, you charge the battery, and then the inverter convert back to DC to AC, and then connect to the load. So normal condition pun it will passing through the UPS sama. So the UPS working together, utility kan. During normal tu pun dia function macam biasa kan. Okay. And then during the battery backup, dia kata ni mana dia dah, all power supply the load pass through the nampak, dia pass through the charger inverter which together perform double conversion lah, AC DC, DC to AC. Kan tadi kan masuk solar charger AC to DC. Ni this is solar charger lah, battery charger. And then from that DC to AC from the inverter. So inverter convert back to the AC. So the best thing when we have this one is our output voltage and current output from this conversion, we got a very good quality of the supply lah. So that the best of the online tu. Macam kita ada satu filter lah kan. Satu filter yang supply from the TMB, we got passing through filter, and then we got a very clean output, very clean supply. Suddenly, let's say when we have interruption from TMB, the inverter and battery step in to ensure continuous. Power to load, samalah konsep bila no supply, so battery tu and inverter will power up and backup until the time. And then the last mode, bypass mode, sama macam tadi. So this type UPS generally equipped with static bypass. So this model it have a static bypass ataupun static switch lah. So the load can be transferred without interruption using bypass AC ni. Bypass AC ni, yang ni lah. So kalau kita nak buat maintenance kan. And then with utility of standby power depend on solution in the event of the following: failure ke, UPS failure ke, load current transient ataupun load peak. So we can use the bypass if we dealing with that issue. So we can bypass directly using this switch. So that's all. Slide from the Mr. Hasnizam's slide lah. So I already covered the topic of the UPS and what you should know. Just cover until that thing lah. Very simple ya UPS ni. At least you know what is the UPS and how to sizing. Okay, how to sizing. So you got the value of your load to backup, and then you plus 20% up to 30%, let's say lah kan. Katakan you nak tambah 20% boleh, you nak tambah 30% boleh. Dalam standard dia cakap 30%. Normal JKR dia just add up 20% sahaja. So can be macam it's same with your design of the DB kan. Your DB you add up for spare 20% up to 30% kan. So sama lah macam UPS pun sama. How to sizing the UPS sama macam you design DB. You just let's say you have a number of essential load, and then you just plus 20%, and from that you convert into the kVA, and from there you just download the data sheet of the UPS. You find out from there which one is a suitable size for your project. Okay. So I think that's all, and then little bit information related to your test because I already prepare for your test nantilah, which is we are scheduled on week 15 ke 16 our test kan. Our test will be held on last week on 8 malam lah, 8 PM lah. So around 2 hours, maybe 8 to 10 PM. You will deal with 2 questions with 3 topic lah. So the topic it will cover lighting, power factor and also cable lah. So you can prepare from now lah. Try to study and try to understand clearly on that topic. Okay, so that's all for me. So this week very fast topic because the topic very easy kan. So is there anything that you want to ask me related to this topic or whatever topic? Ada tak? Yes, our test is face to face. Sebab kami tak buat dah online because when we dealing with online question, we need to develop different question for every student. Dah 2 tahun dah saya buat soalan macam tu. So tak tahulah subjek lain, tapi subjek saya memang saya buat macam tu. So every student dia akan dapat soalan lain-lain terus. So saya tak larat dah. Saya dengan Cik Zam tak larat untuk buat separate question dah. So we decide